Before we move on to faults, let's go ahead and do a quick review of all of our different boundaries because, again, this is such an important thing for you to know. So this is a diagram that's just showing you all three types of boundaries. So right here we have a oceanic convergent boundary, and you can tell that because you have two ocean plates that are coming together. You have the trench going above the subduction zone. This is the subduction zone. As that plate gets melted, it goes up and turns into volcanoes. So that's your oceanic. Your transform is shown right here along a divergent boundary, which is kind of weird. But you can see how one plate's gone one way while the other plate's gone the other way. So they've moved side to side. So that is showing your transform boundary. So let's see. Right over here is a divergent boundary. So one plate's going this way, the other's going this way. Magma comes up. It will cool and condense or it will cool and, well, not necessarily condense, but it will cool and harden to create new ocean floor. So you have seafloor spreading, and you can see the little bumps, which are the ridges, and then the line going straight down is going to be that Rift Valley. And then the last one to look at is we have our oceanic convergent boundary. So we have one plate going this way, oceanic, and a continental one going this way. Again, you have your subduction zone. You have the trench along the whole subduction zone, and this will go up to create volcanoes. So you can see all of those there. It's very likely that you could see pictures like this on your test, and they will have it labeled like A, B, C, and D, and ask you questions based on that. So make sure you do understand diagrams like that. But now we're going to move on to faults. So what is a fault? A fault is simply a fracture that is formed within a rock. And we're looking at the rock that is within the earth. So a fault is a fracture. There are two parts of a fault. You have a hanging wall and a foot wall. So the hanging wall is above the fault line, while the foot wall is below the fault line. And I'll show you that in just a second. But I don't know if any of you have ever broken a bone or had a bone fractured before. Well, if you've ever fractured something, then you probably understand that when we talk about a fracture, we're not talking about a complete break. If you break your arm, then you could have broken your arm in half. If you fractured it, you just have a little crack. So all that a fracture is a crack in the rocks. So we have these crack in the rocks, and they are typically drawn as a diagonal line. So in the diagram below, you'll see that you have a square. This is just how they represent the earth. And so here's the surface of the earth. There's your house and a tree. But deep within the earth, it'll just draw a fault going like this. Now, not all faults are a perfectly straight diagonal line, so not all faults are going to be that perfectly straight diagonal line, but this is just how they represent that. So anytime you see a square or a rectangle broken up into two triangles, they're representing a fault. So the hanging wall is the part above the fault line. So if I was to stand or draw somebody standing like a little stick figure on the fault line, so you have them just standing straight up, then they are standing above the fault line. Therefore, they are standing in the hanging wall, and their feet are pointing down to the foot wall. And that's what you see here. So again, if you draw a little person standing on the fault line, then their head is within the hanging wall, and their feet or their foot is pointing down to the foot wall. So that's kind of how you can tell which is which. Now this is kind of morbid, but I'll tell you it anyway because sometimes it helps you remember. I hate to even say this, but they will have people say if you hang somebody from the hanging wall, then their head is by the hanging wall and their feet dangle in the foot wall. Again, that's a super morbid representation that a student came up with one time, but if it helps you remember how to tell the difference, then I am willing to share that memory trick. I like to think of the nice, happy person standing in the foot wall. So he stands in the foot wall, so his head is within the hanging wall, and his feet are pointing down to the foot wall. So hopefully you have that. We will do a little bit more practice with the hanging and foot wall as the slides go on. So there are three types of faults. This is the first type of fault. So we have three total. This is number one. A normal fault is when the hanging wall moves down. And we're always looking at it relative to the foot wall. Do we necessarily know which one moved? No, but when we look at it, we can say relative to the foot wall, which one, the hanging wall, does it appear to go up or does it appear to have moved down? So looking at this fault, this is a real life fault, and this one is your nice pretty diagonal line. I'm going to just outline the fault line going straight down. So here's your fault line. I want you to think to yourself which one is the hanging wall and which one is the foot wall. If you said that side B is the hanging wall, you would be correct. So again, I draw my nice little happy man standing on my fault line. There, he's happy. So he's standing on the fault line. So his head is within the hanging wall and his feet are pointing down to the foot wall. And so as we see, if you're looking at this nice stripe of red line within this rock, the hanging wall looks like it moved down. That is why we call it a normal fault. The hanging wall appears to have moved down, so therefore it is called normal. So that is your normal fault. Let's go ahead and look at our next one, which is reverse. So this is going to be the opposite. So again, here's a fault. And this one they are already kind of outlined in red, but I'll go over it in yellow for you. There's the fault line. Again, I want you to think in your head which one is hanging, which one is foot. So just think it in your head. If it's easier for you to look at this diagram down here, you can. Okay, so side A is the hanging wall. If I draw a little person standing, his head's in the hanging wall, his feet are pointing down to the foot wall. So in a reverse wall, the hanging wall appears to have moved up. So they have, again, a little section of rock that's outlined in green. And this side appears to have moved up from over there, so therefore it would be a reverse fault. Really, the only thing you need to be able to see from a picture is probably just going to be which is hanging, which is foot wall. And then just know that if the hanging wall moves up, that's reverse. And if it moves down, it's going to be normal. I doubt that they will give you a picture and then tell you to pick out if it's reverse or normal. I think they will tell you how it moved or make it very obvious. They won't give you a picture like this one because that's hard to see. But they may give you like a diagram like down here and make it much, much, much more clear on what's moved up or down. You can think about normally, if you fall down. So a normal fault moves down. And reverse would be opposite, so it moves up. So normally if you fall down. And reverse is going to be the opposite, which is up. So just with a little bit of practice, you'll easily be able to tell the difference. So let's move on to our last one. This is called a strike-slip fault. So we had it move up for reverse, down for normal. Now we're looking at it move side to side. Notice with the road here that you don't have any difference in elevation. So if you were to do one of these other faults, you could go like this and draw it. So this would be the hanging wall. This would be the foot wall. The hanging wall appeared to have moved down. So therefore, this would be a normal fault. But you can see there is a direct difference in elevation. This is much higher than this is. But notice in this picture, everything is even. Because nothing moved up, nothing moved down. It just moved side to side. So if you were standing on this road and there was an earthquake, then you'd be like, here's my guy screaming because there's an earthquake and he's scared. So you had your earthquake and then all of a sudden you're standing and you have moved to the side, but nothing moved up, nothing moved down. So that's strike slip. So it slips and it goes side to side. So normal fault goes down, reverse fault goes up. Strike slip is simply side to side. And I'm sure you have it all written down. I know that's kind of a lot to take in. I promise it's not going to be as bad as you're thinking. We'll do one more practice with your identifying the hanging and foot wall. What's the hanging wall for number 1? And then think, what's the hanging wall for number 2? Just want you to think about that. Okay, let's look at number 1. So again, I'm going to draw a little man. I'm going to change my color because yellow is getting hard to see. I'm going to draw a little man standing on the fault line. His head is in the hanging wall and his feet are in the foot wall. So B is the hanging wall, A is the foot wall. Let's look at number 2. Again, I draw a little person standing there. His head is in the hanging wall and his feet are in the foot wall. Now, if it was going to ask you something, it could say, if A moved down, what type of fault would that be? And you go, oh, the hanging wall moved down, therefore it is a normal fault, because typically you fall down. That's what's normal. Or it would say, if over here for number 1, it would say, if B moved up, what kind of fault would it be? And you say, well, going down is what's normal, so going up is reverse. That's opposite, so this would be a reverse fault. That's the type of question that they would ask you. They may get you to identify what's hanging in foot wall and then say if something moved in one way or the other, what would it be? So hopefully y'all feel pretty comfortable with that. If not, please ask people in the room or send me an email. You can also look up videos on identifying hanging in foot wall. But again, this isn't going to be a huge part of this section of the notes. I'd rather you study more your boundaries because that's more important than this is. So now we're going to take a quick brain break. So try to blink with one eye and snap with the opposite hand. So everybody blink with or wink, I guess you'd say, your left eye. And at the same time, snap your right hand. And then try to switch and wink your right eye and snap your left hand. And see how quickly you can do this. You can pause the video while you try this brain break. Okay, hopefully you enjoyed that. I always like watching people because it tends to be kind of funny to see some people. But now we're going to move on to chunk 1 of your study guide. So we have covered quite a bit of material in Unit 4 so far. So we're going to kind of recap and review all of that with the first part of your study guide. So y'all can end this video while you work on that first part of your study guide.